Hi everyone, this is Yunling. I'm associate professor from Shanghai Jiao University. And today I'm going to talk about our approach to enhancing reference-based phishing detection by knowledge expansion and a counterfactual interaction. And this is joint work between Shanghai Jiao University and the National University of Singapore. I assume that all the audience here are quite familiar with this phishing attack. And as for the consequence of phishing attack, when your account is lost, you might have the financial loss, and your account might be used for deliver misinformation, and your reputation is at a stage. And a phishing attack is always, it usually be served as a first round attack, and a lot of following attack will happen after the phishing attack. So for state-of solution, we believe that it's kind of called a reference-based solution. Comparing to the traditional blacklist-based approach, or the binary classification-based approach. And the reference-based approach usually have the advantage of high accuracy, high timeliness, and high explainability. So for reference-based approach, we usually keep a reference list, while each entry is described by a domain and its corresponding brand representation. For example, we have a domain of Facebook account, and its corresponding brand representation could be its logo and could be its screenshot. And a lot of approach, such as the visual fishnet, Fishpedia, and fish intention are developed based on this reference-based approach. And once we have these reference list, so given an arbitrary web page, if this web page present certain brand intention corresponding to the brand presentation, for example, this web page render logo representation such as Facebook. In contrast, if its domain is not corresponding to the matched domain, this inconsistency gives us alarm, and we will report it. The reference-based approach will report it as phishing. This approach is very intuitive and very logical, and this approach allows us not only to report the phishing, but also explain why it is a phishing, right? It's inconsistent logic is there. And also, we could know what is a phishing-targeted brand. However, this kind of approach suffers two limitations. The first one is that given the reference list, the predefined list could be very limited. So we can have 100, have 1,000. However, for a startup company, it could be very new. It's very hard to be put into the predefined list in timely. And the second, so there's supposed to be original well-known but not a global well-known brand. For example, a bank in Africa. So this kind of logo can hardly put into the reference list. And the second, we observe that some of the phishing web page have very ambiguous brand. And in this case, they're phishing, they're take credentials, but it's very hard to infer what is the intended brand there. Therefore, in this work, we propose a Dynafish framework, which support any reference-based phishing detectors with two components. The first component is called the brand knowledge expansion component, which means that given a web page, we detect the brand intention, but its brand is not recorded in the reference. We try to construct such a reference on the fly to augment the list. And second component is called the web page interaction, which means that a given web page, it has a very ambiguous brand intention, and how do we use some behavior analysis to detect this still phishing? Now let's start with the brand knowledge expansion. So here, the fundamental challenge is that given an arbitrary web page, it could be benign, it could be phishing. And how could we convert and construct a reference based on this web page? And here, our insight is that to decide whether it is a phishing or whether it's malicious is hard, but we can use some simplification. The insight is that the popularity can be used as the benignity. The idea is that the phishing web page is very hard, have no interest to let this web page to last for a long time for societal publicity. So usually very hidden. So in this case, we reduce the phishing detection problems into a popularity detection problem, which is a much easier problem to solve. So here, we list the 3 conditions for decide whether it is a benign web page, so without any additional reference. So first is that this web page must be popular, which means that it has to be indexed by the state-of search engine. And the second is that this web page is supposed to be recommended in a very high ranking. And last one is that the web page has to be alive for a long time. That is based on observation that the phishing web pages usually be alive for a very short period because they want to avoid being tracked. And they also know that they will be blacklisted very soon. So a long lifespan is a very anti-feature for the phishing web pages. So based on this idea, we try to validate 2 hypotheses. The first hypothesis is that we assume the website is popular. So in this case, we try to have these domain information and take its descriptions and feed into the search engine. And the search engine will return several high-ranking recommendation. We're going to see whether the domain will appear in this kind of recommendation. And then the second hypothesis is that we're going to assume that the website is phishing, and we try to, but it will targeting for a popular logo. So in this case, we will try to extract a logo on the web page based on our the logo detection approach, and then we'll feed this logo into a Google service, and we'll have this description of the logo. And giving this description to the search engine, it will recommend a few high-ranking recommendations. We're going to see whether the input logo will appear in the returned web pages. And these 2 hypotheses, the intuition is very simple because we just do this kind of the cross-validation technique to check this information consistency. And there's some corner cases, and we deal with these corner cases with our algorithms described in our paper. And for the second component is we call the web page interaction. And for this interaction, and we call it counterfactual behavior analysis. The idea is that given an arbitrary web page, website, we assume that it can validate its user credentials. So if we feed an arbitrary, random, fake user credential to the websites, if it can take this credential, we believe there's something weird. And based on this idea, we implement a web page interaction agent, and we fill in the form automatically and observe its behaviors to decide whether it is phishing websites. And we conduct 4 experiments, and for the sake of time, which I just reported 2 of them. The first is called a closed word experiment. We're going to evaluate our approach on a collected data set. And basically, it is a phishing case data set. And the second is we'll conduct an open world experiment, which means that we'll run phishing detectors on the internet to see how much zero-day phishing websites we can collect. And because our approach is interactive approach, which means that all existing data set cannot be used in an effective way. So existing data set have the URLs, have the HTML, have the screenshot, but they are not alive. They cannot be interacted. So in this approach, we construct our own DynaPD dataset, which collected over 6,000 interactable and alive phishing websites. So basically, we collect the phishing keys and deploy it on a virtual machine. And on this screenshot, you can see that there are a list of the phishing website in terms of the hyperlinks. And the user can design their algorithms, interact with the web pages, and to see whether their approach really works. And this is the result. We can see that for existing approach like a Phishpedia and a Phish intention, it keeps a very high precision on the data set. However, their recall is not that optimistic. And when equipped with our DynaPhish framework, we can improve Phish intention by 28% and increase recall of Phishpedia by 30%. In addition, we can find that the size of the reference list will be augmented by 10 times, more than 10 times. And also in our open world experiment, we try to take the zero-day or emergent phishing websites from the search string, and we crawl 3K websites every day, and we run it for more than a month. So we totally have close to 100K websites. We're going to run our phishing detect engine against those kind of websites to see how many phishing websites can we have. So here are the results. we can see that for when equipped with Dynafish framework, and both phishing detection engine will increase their reference list by more than 20 times. And also we can find that for phish intentions, the recall has been improved by 61%, and the Phishpedia the recall is improved by 74%. However, comparing to phish intention, Phishpedia, the precision of Phishpedia dropped a little bit. And also, we can see that when equipped with this Dynafish framework, both phishing engine find 10 times more zero-day phishing websites. And also, we have two observations based on the approach. So the first is that we find that usually we believe the phishing websites targeting for very popular big companies like Google, Facebook, etc. But with the augmented reference list, and we find that there are some small but popular websites which still serve as the target of the phishing websites. So we can see that we do have the Cisco, Microsoft, but also have some company like the Sonic War and the Rancor Key, something like that. People are not that familiar with that brands, but they're still fall prey to the phishing attack. And the second is that we find the phishing campaign is very dynamic. So we can find that for the first 5 days, Microsoft, Facebook, Apple were supposed to be top 3 targets. But for the next 5 days, we can see that Instagram's jump into the top 3 ranking. And in the next 15 days, we find the Sonic War became popular in terms as the phishing targets. So here comes the takeaway. So first is that we provide a framework called the Dynafish. So that is the framework to enhance all existing phishing reference-based phishing detection agent, and we find that they can significantly improve the recall and significantly augment the reference list. And the second is that we deliver Dynafish dataset. So this dataset contains all alive phishing websites. We know that for the phishing researchers, people have the difficulty to try the phishing websites because the website can be only alive for maybe 3 days, or at most 1 week, but we provide a lasting environment for people to interact with these phishing websites. And finally, we observe that the phishing campaign is very dynamic, and it can even target for popular small company. Yeah, that's all from my talk, and willing to take your question.